Welcome to another episode of Rocking It Down the Pub. The last one was actually proper rocking it down the pub. There was Jägermeisters and everything going by and everything went, and it did rock. It was Thursday night.
No,
What have we been through tonight already? We went through
all martial arts,
all the different styles of martial arts and all the different areas and everything, and then we went through the birth of the discovery of radiation and uranium and everything. But I'm thinking there's a couple of subjects that some people asked me that we wanted to talk about. Back on the subject of the Robert Mugabe thing.
Nasty man.
Amin.
Oh,
back on him. Hold on. Amin. And hold on. I think it was Chris Waters that requested this, and at the risk of staying on the same sort of subject of South African dictators. But we will do this Idi Amin thing.
Idi Amin.
Okay, so Idi Amin.
This is actually quite funny. You remember the TV series Ask Aspel? You'd request to see somebody again. Well, he had a guy that worked for him, a British guy, called Bob Astle, and he'd talk to him. He'd never see people again. He'd be fed to the crocodiles. But he actually was overthrown as a...
Who got fed to the crocodiles?
No, Bob Astle used to feed people to the crocodiles.
Bob Astle?
No, we had in England, you'd see the TV programmes. If you wanted to see something again, or someone again, you'd ask Aspel.
Right.
Idi Amin used to ask Bob Astle, and you'd never see anywhere. He was the head of his secret police. He used to make people vanish, and so... It's a play on the words.
They fed them to crocodiles?
Yes, or threw them out of it.
It's a bit like Bricktop, who fed people to bricks, pigs, sorry.
Yeah, or whatever, but Mr. Astles was the head of his secret police, a Brit. No, but you can see he had his, might have been a mad cat, but his own people overthrew him, and he became...
Idi Amin?
Idi Amin, and he became...
Well, he was Western. He was... coming up in the ranks with the Western and the capitalists and all that sort of stuff, and then he got swayed and got into communism and went in with the Russians and all that sort of stuff.
Bad news.
Yeah.
Well, obviously they were obviously into funding, weren't they, and all this sort of stuff, political sway and influence. But Ugandan Asians, quite a lot of them are over here, very nice people, worked hard and came over poverty stricken. Some have made it and do it well, because there were people that wanted to achieve, like in Kenya, people want to strive and achieve. Those that want to achieve. Those that don't. No, it's people are people. There's survivors and there's not.
You get idiots in all sorts of races, don't you, definitely. Okay, so we did Idi Amin. The next subject I wanted to talk about tonight was space-time continuum, or space in general, and this one was requested by Louis Barnes, I believe. So space in general, which is quite an open subject. So,
well, all the scientists reckon there's a finite amount of matter spread out, but I think there's a little trick that they've missed, saying everything is all these big spiral galaxies and it's so far away from the distances. So theoretically, you could actually be seeing the same star 3 times in different parts of its travel through space as it goes round the spiral. So it might be named 3 times, because when it started initially, it was so far away to see it, and then the next time you see it, when it's because light travels in straight lines, whatever, it's lined up. It could have progress. So
but the light is. Does it travel in straight lines? Because it
can bend, it can twist.
Yeah.
Magnetism and gravity can affect light, even a particle.
Well, because they can't decide whether it's a particle or a wave. So, and it is affected by gravity.
But if it's actually a spiral, so that means it's moving in a pattern. So how do you know in history where it is in that spiral? You could actually be saying it 3 times.
How can you be seeing it 3 times? Surely you'd be able to see it moving.
No, but you're seeing it moving 3 times. If it's moving out, if it's a star, it's going round in a spiral and it's expanding. The galaxies are expanding; they're not contracting. and it's travelling in the spiral arc.
This is a fallacy, because on the word of expanding, things aren't actually expanding. The galaxies are actually moving apart, because if everything was expanding, then we'd have no knowledge of this, because we'd be expanding at the same rate with everything else. So in the ratio, in the
But
ratio,
we're only in our own.
the galaxies are moving apart. They're rushing apart. Which means it does give way to the what do they call that? They call it it's not the flat. They call it the open galaxy, where everything will move so far apart. All the atoms and everything will be so far. They'll be so far away. There's no chance of any atom anything colliding with anything else. And everything moves so far apart, it will just disperse.
That's a little thing.
There's open, closed, and flat.
No, the open galaxy is that little bar of chocolate, you know, when you leave it open, some little fecker's going to steal 2 bars and deny technology. He's going to deny.
And it's going to disperse. So that,
But you could theoretically, because the time distances, the time periods are so long, you could actually be seeing the same thing. It's far.
That's a hard thing to get your head around.
Like everything.
I'll tell you something else.
It's mumbo jumbo. You're playing them.
I know. Well,
so lots of these things can be proved.
It's conjecture, isn't it?
It's only because somebody brainy says it's got to be true. Like, how many things have they found to be false?
Well, you could.
Or are only true on Earth.
Yeah, but you could say there's a chocolate teapot that floats around the world. But you got to have an educated guess. You can make up any crazy theory that you wanted, but you know these guys are quite educated people. And they're not like.
No, they earn vast fortunes. They propose, and everybody jumps on it until they're proved wrong. Then it takes a whole. The worst ones are archaeologists. You get some come up because he's famous or rich. We believe that as a theory. That half of the archaeological facts that they were told, in fact, have been told being total bollocks. You know, it's when people study it further. Why all these sites have got to be high status? Because it makes them look good. They could be actually.
Well, there was a lot of that going on in the 1800s and stuff, where people were like very unscrupulous in the furtherment of their own careers. Definitely, and they were overthrowing each other because they wanted to be famous. Yeah. And it still goes on to a little bit now. Yeah, it is weird, but I don't think it is quite so rife these days. I think everybody's a little bit more sensible. But getting back onto light and stuff like that, like you're saying, you might be able to see like the same star 3 times everything. That's a hard thing. That's a hard thing people get their head around.
It's either moving out or moving in, but potentially because of the time period, you could have actually possibly
get this one.
Seeing it in multiple periods of time. It's moving.
Get this one right. If you are travelling at the speed of light, and you shine a torch in your hand. Theoretically, you could keep up with that beam of torch and run alongside it and see that beam of light travelling. But it doesn't matter. But it doesn't matter. If you were travelling at the speed of light and you shone a torch, then that light will shine away from you at the speed of light. And the speed of light actually turns out to be the cosmic speed limit, because if you could travel faster than the speed limit or the cosmic speed limit, then you would theoretically be able to travel backwards in time.
Unfortunately, a torch doesn't produce light at the speed of light.
Doesn't it?
No.
What is it?
Well. Just you can see it as invisible. It's a wavelength.
But it's still light, isn't it?
It's still light. No, but it is not. A torch doesn't. That isn't the speed of light. The speed of light they're talking.
But the light that comes out, it must travel at the speed of light.
Eventually, but it isn't the speed of light.
Even
radio waves don't travel at the speed of light.
That's because they're not light. It's only light that travels at the speed of light, which is light is the
now,
only thing that travels at the.
What you're calling light of that visible beam isn't light.
What is it?
Per se, it's a little bit in the spectra in what we can see in our visible spectra, which is a very narrow bandwidth of.
Yeah, because you've got ultraviolet light and all these other things that are going on. But do they not travel at the same
radio waves? Because you've got lots of things that travel which are far lighter than like other beams and waves,
Well,
like X-rays.
this is where you start getting into quantum physics, because where quantum physics is the quantum leap, of which is what the electron is around the nucleus of an atom. And
from the micro to the macro scenario, they're trying to assume
apparently
they're
if
the same. One on a bigger scale, they're trying to apply a general rule.
Well, they can't. Everything works well with Einstein's theory on the macro world, but when it comes down to the physics of atoms, it falls to pieces.
Yes.
And apparently, if you're not first outraged by the physics of atoms when it's explained to you, you never truly understood what's been said to you. Now, the thing with the quantum physics is the electron, which orbits like a cloud around the nucleus of an atom. Apparently, the number of neutrons and protons give it its identity, and then the orbit of which the electron circumferences the nucleus gives it its character.
Yeah.
Now, this can jump from certain points to another, but the thing is, what's bizarre with it is the electron jumps and is never actually observed travelling in the space in between. And the only conclusion they can come to is, as far as the electron's concerned, the space in between the orbits does not exist. And that actually travels faster than the speed of light, because it is instantaneous. Although it's a tiny little space that it travels, but it instantaneously disappears here and reappears here.
Yeah.
Which reminds me again of like Star Trek, where you know they beam people down and have their atoms disassembled and reappear somewhere else.
What's that experiment they did from CERN to some place, firing a beam through a mountain, and they couldn't understand.
Oh, well, there's
it was travelling faster than it should have done. But if that mountain is absorbing those neutrinos, it was the speed of a neutrino they were trying to measure through this big lump of rock through Switzerland and thing. But if that lump of rock is absorbing neutrinos all the time, I think it's just their neutrino they're seeing. But if they're there, it's a bit like a ball, like you see Newton's cradle, click, 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 click. If there's already neutrinos there and they're fired, it's going to ping. It's not that one neutrino they're fired they're going to see. They're going to see all the other bloody neutrinos that are floating around.
Right.
They haven't.
They're just knocking around generally. Jaywalking and stuff.
That's why you've got all these grids.
Hanging around on street corners. These
and they're
neutrinos. Troublesome neutrinos.
Some of this rock. But they haven't sort of taken into account. Supposing there's all these neutrinos that are already there, they've still got their energy.
And you've got
it's not the same one.
Chavvy neutrinos.
Yeah,
just knocking around.
Just accelerated and hence
smoking grass and stuff.
They found something faster than the speed. They thought it was faster than neutrinos. I can't remember. It was something like 300 kilometres, and the time travelled.
Isn't there a certain? I can't remember exactly what it is. There's a certain amount of spin on a certain particle. I don't know if it is an atom or a subatomic
they've
particle.
got all these other bits. They've got all these quarks.
They would have made that.
All these
but there's a certain amount of spin on a sister particle or something like that. And it doesn't matter what the distance is. One spins one way and the other spins the other way.
Yeah.
And the information between the two, if you spin one atom in one direction, another one, which could be, I don't know, somewhere else, instantaneously records this and spins in the other, and again this information travels faster than the speed of light.
Allegedly. But lots of things you've got people tied to one set of theory. They don't look elsewhere why this can happen. Everything has boundaries, divisions. All rules have parameters. Outside those parameters, they're not true. It's like, what is the boiling point of water?
Well, it's what we record it as.
No, 100 degrees C.
Yeah. At this atmospheric
pressure.
Because if you go into space, your blood will boil at 37.5 degrees because of the atmospheric pressure, which is none.
That's why you can't boil an egg on the top of Everest. But there again, if you've got a butane powered, it won't actually light anyway because it's too cold.
It's quite amazing, that we can only exist in very small
eyes. Well, we used to see things with I worked in a scientific, and